Hello. We're going to talk about a new math rule. It's called when multiplying, it's got a great name, or dividing both sides of and I'm going to box this word because it's important, inequality by a negative value, and we'll box that as well. So when multiplying or dividing both sides of an inequality by a negative value, flip the, I'm writing in all caps, sign. Okay, so we're going to make a little note here. So what does it look like when solving for y? Dot, dot, dot. So I'm going to put a little cloud around this. So these are not complicated notes, but I just thought if you write it down, it might have a better chance of sticking in your brain. So what we're looking at is, we're thinking about inequalities, right? So we can kind of draw some inequalities here. In the middle, I can put a not equal sign. So when we're thinking about inequalities, right, and we're multiplying or dividing both sides of inequality by a negative value. So think about solving, right? So when we're solving for y, we're going to look at just a couple examples here. Example number 1, and just so you can see it next to example number 2, right? So for example number 1, you can see something like this. X plus y is greater than, let's say 12, right? And then over here, we'll say x minus y is greater than 12. So one of the strange things about inequalities, right, is that they're not really balanced in the same way that an equation is, right? This side is greater than 12. This side is greater than 12. So when you encounter negative values, right, you think way back to the first time you saw a negative number, right? You know how, like, let's try to just draw a little note here. So if here's 0 and here's 1, 2, 3, right? The numbers get bigger, so we're moving in a greater than direction. But on the left, right, you'll notice the numbers are getting, or the actual like value is getting bigger. It's moving further away from 0. But as they do that, they're going down, right? So it's kind of the opposite of what you would think. And so because of that, when we encounter negative values in an inequality, right, we need to flip the sign. So here, x plus y is greater than 12. To solve for y, I'm going to subtract x from both sides. Right, and so we've seen this before. Basically, nothing about what I just did is going to be different than what you did. The only difference is, in terms of visually, you're going to see a symbol here versus the equal sign. So that's the only difference, right? You're still changing both sides to get y by itself so that we can graph. But this is no flip. Okay? Here, x minus y is greater than 12. When I take that x away, y is still not by itself, right? That negative is attached to it. So if it helps, you can put a 1 there. So negative 1y is greater than negative x plus 12. When I divide negative 1 here to make that go away, right? Because the opposite of times negative 1 is divide negative 1. And I do that to everything else in the problem. Remember, this looked very similar to this. Here, divide, divide, divide. When I do that, it's going to actually flip the sign. And it has to do with, we're talking about opposites. So when I divide negative 1 by negative 1, and I change this negative y to a positive y, I have to think about it in the opposite direction. Negative divided by negative, so that's still like the solving process is going to be the same. The only difference is, and I'll just take a little highlighter here so you can see it. So we're going to say flip the sign. Okay. And so the big idea here is that if you see y is negative, right? So here, y is negative, the sign flips. Here, y is positive, the sign doesn't flip. Okay, I'm going to just do a couple more real quick so you can see again. So example number 3, example number 4, right? So you may have seen a version of this when you guys solved for x in 7th grade, but it doesn't hurt to see it again. It definitely applies to when you're solving for y. Okay, so example number 3, let's say that there is 2x minus 4y is greater than or equal to, let's say 20. And then we have 2x negative plus 4y is less than or equal to 20. So in this situation, you're looking to see, right, where are we going to flip? So I'm going to use my highlighter again. So here, y is negative. Here, y is positive. I'm going to go ahead and circle that. There's your flip. Okay, because y is positive here, right, we're not going to flip anything. It doesn't matter that this is negative. You're just looking for the y, because eventually what's going to happen, right, when we move the x, y is going to be by itself with a number, and because it's negative there, then we're going to apply our rule up here, right? So 2x minus 4y, I'm going to get rid of my 2x, get rid of my 2x. Notice I haven't changed anything about the problem yet, right? But as soon as I divide by -4, each term, that's when I'm going to flip. Okay, so in that situation, right, I'm going to change the direction. Instead of being greater than or equal to, it's less than. Then everything else is the same. -2, -4, negatives cancel out. 2 over 4 is the same thing as 1 over 2. It's just a half. 20 divided by 4 is 5, negative. Okay. Good. This side would be easier, right? Because it's like, basically I see a negative 2x. What's the opposite? Plus 2x, plus 2x. I bring down the positive 4y. I bring down the sign. Cancels. 2x positive plus a 20 positive. And then one more step, right, which is just to get rid of that 4. So nothing is unusual about this because y is positive. So there's no flip here. So if you can just train yourself to look for the y's, if the y value is positive, it doesn't flip. If it's negative, it flips. That is all. Although I guess you could do this. 4 divided by 4, 2 over 4 simplified, and then 20 over 4 is 5. Just to be complete. All right. When in doubt, remember your golden rule. If you see y is negative, flip the sign when solving for y.